In this question, we are given that a bullet loses 1 by nth of its velocity passing through one plank. The number of such planks that are required to stop the bullet can be. Here, if you can recall, the similar question we already analyzed in motion in one dimension, where we consider inside the plank the acceleration remain constant and all the planks which are being used are identical. Now in this situation, if we visualize the case is this, where we are having a plank of thickness x on which if a bullet is fired and say bullet velocity is u, the bullet comes out with the velocity here, it loses 1 by nth of its velocity. So the velocity here is u minus u by n, because u by n is the velocity which is lost. And in this situation, we can consider inside the acceleration is constant, or we can say the work done due to friction inside is the cause of loss in kinetic energy. So either ways we can solve it. So let me use it. Let me solve it by using the speed equation like the way we did before, and you can also verify it with the help of work energy theorem. So here in this case we can write, if plank thickness is x, here we use u multiplied by 1 minus 1 by n whole square is u square minus 2ax. Here I have used a to be the acceleration inside the plank, and I'm using v square as u square minus 2ax. So here this gives me the value of 2ax, which is u square multiplied by 1 minus n minus 1 by n whole square. On simplifying, this will give 2ax is equals to u square. If you square it, n square minus n square plus 1 minus 1, n square gets cancelled out. There's 2n minus 1 divided by n square. So this is our first equation. And the same acceleration we are going to use in case when there are n planks like this. One, two, three, up to say if n planks are used, then the total distance will be nx. And if the bullet is fired, we are required to find the number of planks, so that with the same speed if the bullet is fired, finally when the bullet reaches the last plank, here its final velocity should be 0. So here using constant retardation, we have here we can write v final is 0, so 0 is equals to u square minus 2a. Distance now will be nx. So we can substitute the value of 2ax from here. So this gives a u square is equals to n times 2ax if we substitute this, and u square multiplied by 2n minus 1 by n square. Simplifying here, u square gets cancelled out and the value of n we are getting is n square by 2n minus 1, which matches with option A. So answer to this question is option A.